My name is Kareem Khalifa, and today we'll be discussing the logic of conditionals. Today, we'll start by looking at informal reasoning with conditionals, then we'll look at formal reasoning for both conditionals and biconditionals, and conclude with some proof strategies. To begin, we'll look at four methods of informal reasoning involving both the conditional and the biconditional. Our first rule is modus ponens, what we'll use as the elimination rule for if-then. Here's an example. If Clapton is a great guitarist, then Hendrix is the greatest guitarist. Clapton is a great guitarist. Therefore, Hendrix is the greatest guitarist. Here's the more general pattern for modus ponens. If P, then Q. P, therefore Q. In our example, P would be Clapton is a great guitarist, and Q would be that Hendrix is the greatest guitarist. Our second rule is called biconditional elimination. You can also think of this as biconditional modus ponens if you'd like. Here would be an example. Hendrix is the greatest guitarist if and only if no other guitarist is better than Hendrix. Hendrix is the greatest guitarist. Therefore, no other guitarist is better than Hendrix. The more general rule for this is P if and only if Q, P, therefore Q. In our example, P would stand for Hendrix is the greatest guitarist, and Q would stand for no other guitarist is better than Hendrix. Unlike regular conditionals or material conditionals, biconditionals go in both directions. Hence, the following is also a legitimate application of biconditional elimination. P if and only if Q, Q, therefore P. Thus, the following would also be a legitimate application of biconditional elimination. Hendrix is the greatest guitarist if and only if no other guitarist is better than Hendrix. This is exactly the same as the previous example. But now, our second premise is no other guitarist is better than Hendrix, and from this we infer Hendrix is the greatest guitarist. Next, let's look at contraposition. Here's an example. If Hermione is a wizard, then Hermione can cast spells. Therefore, if Hermione can't cast spells, then she's not a wizard. Here's the more general framework for contraposition. If P, then Q, and from this you may infer, if not Q, then not P. Finally, let's look at conditional proof, which will turn into our arrow introduction rule when we formalize these things. Here's an example. Suppose that you major in philosophy. Then your analytical reasoning skills will be honed, which in turn will increase your chances of rocking the LSAT. Therefore, if you major in philosophy, you will be likelier to rock the LSAT. This one's a little bit looser, but that's okay for now. We're just trying to get a feel for the rules. Because we're merely supposing that you major in philosophy and not actually asserting it, we can think of this as a subproof. Here's the more general rule. From a subproof of Q from P, infer that if P, then Q. So in our example, P would be that you major in philosophy, and Q would be that you're likelier to rock on the LSAT. Okay, having looked at informal rules for conditional reasoning, now let's turn to formal rules. And we'll start by first looking at the arrow elimination rule, which is basically like modus ponens, and then look at the arrow introduction rule, which basically is like conditional proof. Okay, so our first rule is arrow elimination, and we see that this is just modus ponens. This is just the example we had before with Hendrix and Clapton. Right? So from if P, then Q, and P, infer Q. Let's walk through a formal proof of our previous example. So let's represent Clapton is a great guitarist by great open parentheses, Clapton close parentheses. And similarly, Hendrix is the greatest guitarist with greatest open parentheses, Hendrix close parentheses. And you can see why we've represented the proof just as we have. The only thing we need to add to this is a rationale on line 3, and that's just going to be arrow elim 1, 2. Let's make sure we understand why that is. So here's our rule for arrow elimination. From if P, then Q, and P, infer Q. We see that Clapton is a great guitarist is playing the role of P in this application of arrow elimination. And we see that Hendrix is the greatest guitarist is playing the role of Q in this application of arrow elimination. And finally, we can see why we put 1, 2 on line 3. Line 1 corresponds to if P then Q, and line 2 corresponds to P. Therefore, this is the correct application of arrow elimination. Now let's look at arrow introduction. As we'll see, this is just conditional proof. Thus, the rule is from a subproof of Q, from P, infer that if P then Q. And our example of this before was basically showing how if you majored in philosophy, you'd be likelier to rock on the LSAT. Let's walk through that example. So let's begin by setting up our translation key. We'll represent you major in philosophy as philosophy, open parentheses, U, close parentheses. We'll represent your analytical skills improve as analytical, open parentheses, U, close parentheses. And we'll represent you rock the LSAT, or you're likelier to rock the LSAT, as LSAT, open parentheses, U, close parentheses. When we did the informal version of this proof, remember I said it was kind of loose. And you can start to see why that's the case. There were in fact 2 hidden assumptions, which are our premises. The first assumption says, if you major in philosophy, then your analytical skills will improve. And the second assumption says, if your analytical skills improve, you're likelier to rock the LSAT. Okay, so arrow introduction says that we have to set up a subproof where the antecedent of the conditional we want to prove is basically going to function as the premise. So in this case, what we want to ultimately prove is if you major in philosophy, then you're likelier to rock the LSAT. And so we have to start off with the antecedent of that in our subproof, which would be that you major in philosophy. This is exactly what we've done on step 3. Next, we know that we want to get the consequent to be the end of our subproof. That's going to take a couple of steps. So we're going to do a 2-step process. The first step is basically to show that if you major in philosophy, then your analytical skills improve. And this is exactly what we've done on line 4. Right? We've just basically said, all right, suppose that you've majored in philosophy, then given premise 1 and assumption 3, you can infer that your analytical skills will improve. The next step will just get us to the LSAT. Let's look at that. Here, we note that the second premise says that if your analytical skills improve, then you're likelier to rock the LSAT. And this is exactly basically the move that we make. We use that second premise coupled with line 4 to do another arrow elimination, and we're good to go. So we're now in a position to assert our conclusion. If you major in philosophy, then you're likelier to rock the LSAT, and this is on the basis of arrow introduction. Let's just carefully walk through what's happening on that last line. Recall that arrow introduction says that from a subproof of Q from P, infer that if P, then Q. As we see, we have a subproof going from lines 3 to 5, which is exactly why we list them as our rationale on line 6 in red over here. Furthermore, we see we have exactly the mapping that we need to apply this rule. Right? Playing the role of P is you major in philosophy. Note that this has sort of a double job description when you're using arrow introduction. On the one hand, it's got to be the premise in your subproof, which is what it's doing on line 3. And on the other hand, it's got to be the antecedent in the conditional you infer, which is what it's doing on line 6. Similarly, we see that the statement, you're likelier to rock on the LSAT, is playing the role of Q in this rule. Right? It's once again got a double duty. Right? On the one hand, it's got to be the conclusion of the subproof, which is what it's doing on line 5. And on the other hand, it's got to be the consequence of the conditional you ultimately infer using arrow introduction, which is what it's doing on line 6. Finally, I want to conclude this discussion by showing you that actually our proof really does mimic the reasoning that we did informally when we talked about conditional proof a bit earlier. Okay? We started that informal reasoning with the supposition that you major in philosophy. That corresponds to line 3. Note that it's a supposition, it's a hypothesis. Right? It's not actually being asserted, it's merely being supposed for the sake of argument. Next, we noticed that on the supposition that you major in philosophy, right, your analytical reasoning skills will be honed, which in turn will increase your chances of rocking the LSAT, and that corresponds to lines 4 and 5. Finally, we drew the conditional from that. If you major in philosophy, then you're likelier to rock the LSAT, which is corresponding to line 6. Okay, now let's look at the rules for biconditionals. As before, we'll first start with the elimination rule and then look at the introduction rule. The official rule for biconditional elimination is from either P if and only Q, or equivalently Q if and only if P, and P infer Q. Here's the example we used before, now formalized. This says, Hendrix is the greatest guitarist if and only if no other guitarist is better than Hendrix. Hendrix is the greatest guitarist, therefore no guitarist is better than Hendrix. What we see is that this is just a straightforward application of arrow elimination. Let's just make sure we understand how it works. Simplifying a bit, biconditional elimination says from P if and only if Q and P infer Q. Here we see that P corresponds to Hendrix is the greatest guitarist. Similarly, Q corresponds to no guitarist is better than Hendrix. Combining these, we see that we're just applying the rule, and everything maps on neatly. However, recall that we said that you can flip this in a way that you can't do with a normal conditional, but you can with a biconditional. So if we had, for instance, the same biconditional, Hendrix is the greatest guitarist if and only if no guitarist is better than Hendrix, but now we flip those other two claims so that our second premise is no guitarist is better than Hendrix, we may then infer from that that Hendrix is the greatest guitarist. We motivated that using slightly different notation than what we see here, but it all amounts to the same thing. Let's talk through it. Remember I said that this was simplified. This was the version that we used in the previous iteration of this proof. From P if and only if Q and P infer Q. However, remember biconditional elimination isn't limited to that. You can basically flip Q and P in that biconditional and it's still a good application. And this is exactly what we're doing here. In this argument, Q now stands for Hendrix is the greatest. Note that this is the opposite of what we did with the previous version of this argument. Similarly, P now stands for no guitarist is better than Hendrix. And we see that this fits the mold of this particular formulation of biconditional elimination. Finally, let's talk about biconditional introduction. Basically, this says from a subproof of P from Q and a subproof of Q from P, infer P if and only if Q. Hopefully this is pretty intuitive. Remember that a biconditional is just two conditionals. It's basically the same thing as saying if P then Q and if Q then P. So all you're doing here with a few shortcuts that's allowed by the proof system is basically doing an arrow introduction to establish if P then Q, and another arrow introduction to establish if Q then P, and then conjoining them. And you get to skip a few intermediate steps in there, but that's the basic idea. Finally, let's add to our proof strategies. Recall that the core idea behind proof strategies is reverse engineering your proofs on your scratch paper and then bringing that to your final product. Furthermore, recall that reverse engineering basically involves two questions, and you should be asking yourself this at every step of your proof. What's the main operator of my subconclusion or my conclusion? And what's the proof strategy associated with that operator? At this point, I'm going to assume that you know how to identify the main operator of your subconclusion. And all I'm going to do is show you that with conditionals and biconditionals, there's a few more proof strategies that would arise when those end up being your main operators. Recall that these were the three proof strategies that we have already discussed in an earlier lecture. They involved conjunction, disjunction, and negation, and there's a few nuances there, but as a first rough approximation, the idea is use the introduction rule for whatever your main operator is. Now what we're going to see is this is exactly the same general piece of advice when you have either a conditional or a biconditional as your main operator. So for instance, if a conditional is your main operator, what you do is you follow the advice of arrow introduction. You hypothesize your antecedent as a premise and a subproof, and then you prove the consequent, and then you can just apply arrow introduction, no problems. Note that one thing that's nice about using arrow introduction is, in some sense, it gives you more ammo for the proof. You have all of these suppositions or hypotheses nested in your subproof, and so you can move a lot further than you would if you don't make those suppositions. But the key is making those hypotheses strategically. And that's exactly what you get with this piece of advice. If what you're trying to prove, either as your ultimate conclusion or as a subconclusion, is a conditional statement, you can hypothesize the antecedent. Biconditionals work in roughly the same way, right? What you're going to do is basically do a subproof where you take the left-hand side of your proof as your premise, and then prove the right-hand side, and then you're going to do the exact opposite. You're going to take a subproof where the right-hand side is your premise and prove the left-hand side of your biconditional, and then you can apply a biconditional intro. Thanks, and I'll see you at the next lesson.